Hello learners, welcome to Manifested e-learning platform. We are going to proceed ahead with our topic on rotation, and today we are going to look at point symmetry. So the objective of the lesson is for the learner to understand what happens to other figures, plane figures we learned in the earlier lessons, like a pentagon. We have equilateral triangles. What order of symmetry will they have? How many times will they fit onto themselves when rotated through a complete 360 degrees? So the learner should be able to tell the order of rotation of some symmetrical planes. So we shall try by looking at the pentagon. The pentagon. In the earlier lesson, we learned that a pentagon, any polygon, will have the number of lines of symmetry equal to the number of sides. And we said the lines of symmetry rise from the vertex to the center and strike the center of each side. Like for instance, this pentagon has 5 lines of symmetry. So whatever we are saying, if we have that pentagon, if we rotate it, so I'll do a very practical example with the pentagon. It's going to be very practical. So if I trace these, trace that, trace that, trace this, trace that, trace that, and finish up. So that is what I have for the pentagon. Learner, that is what I have for the pentagon. So I'll look for a way of looking. The center is here. That's the center. The center is the center of the circle that inscribes the pentagon. That inscribes the pentagon. So I'll come there. Come there. I try to see what will happen as I rotate. If after a fifth of the rotation, it fits into itself. You see where 5 was. After 72 degrees, it fits there. After another 72 degrees, it fits there. After another one, it fits there. After another one, it fits there. After another one, it fits there. And it's actually 5 times. It can fit onto itself 5 times. It can fit onto itself 5 times. So if we have that pentagon, the pentagon. For our case here, the pentagon, the order of rotational symmetry is 5. How do we get 5? It is actually 360 divided by the 72. You'll find that this angle, that angle, each of those angles to the center is 72 degrees. After 72 degrees, it fits onto itself. So we say the order of rotational symmetry of a pentagon is 5. We can look at another example also. We have this figure here. We have that figure there. This one is 6-sided. We call it the hexagon. We call it the hexagon. Try to trace it. So that's actually a hexagon. So to get the order of rotational symmetry, we try to rotate, and you realize that angle. You have this angle. Since it is 6-sided and they are equal, the angle is 60 degrees. That angle is 60 degrees. So if you rotate, if I have my center and I rotate, so I'll have point 1. You'll come how many times before that point returns there? So that's 1. It has fitted onto itself. 2. It fits onto itself. 3. It fits onto itself. 4, 5, and 6. So our hexagon you discover it has an order of rotational symmetry equal to 6 with the center of rotation the center of rotation is the center of the circle inscribing the pentagon. We've actually looked at 2, and you've seen what is happening practically. You've seen what is happening practically. We can look at a parallelogram. We have this one is the parallelogram. We have the parallelogram there. So I'll trace it there. A parallelogram. So we have, that is a parallelogram. Parallelogram. We just want to discover it will have how many orders of symmetry. So we fit that one there. I'll fit my parallelogram there and I rotate. So I'll mark a point. I'll start with point 1. So I should come back to 1. So I'll rotate. Lana. I'll rotate. So before it comes there, we shall see how many times it would have. So I rotate. That is the first fitting. Before it comes to the second point is the second fitting. So I can repeat So you saw it, this was the first fitting, and that was the second fitting. So what do you say, Lana? We say that a parallelogram, it has order of rotational symmetry equal to 2. Center of rotation is the intersection of diagonals. Intersection of diagonals. Note that, learner, the same case will be the same is for a rhombus. The same case is for a rhombus. A rhombus will also have order 2, order of rotational symmetry equal to 2. Center of rotation is still the intersection of the diagonals. Intersection of the diagonals. We look at another very common example in our lives. Very common. Very common. Very, very common. Very common. Very common. Very common. That is a circle. That is a circle. For a circle, what you realize, learner, have you ever tossed a circle around? It always comes to fits on itself. However, how many times you rotate, it will still return to that face. Even you push a very small degree, it will still come to that circle. So we say a circle has infinite, not countable, infinite. The meaning of infinite means not countable. At some level, you'll discover that 2 divided by 0 will be infinite. Infinite, not countable. Not countable. Infinity, like the tangent of 90. The tangent of 90. 1 divided by 0. Infinite. So, a circle has infinite order of symmetry. Infinite, we say, you don't say that, we say a circle has order of symmetrical, has infinite, uncountable, infinite order of rotational symmetry. It means it is uncountable. Wherever you turn it, it will still fall on the same circle. It's not like a parallelogram or a pentagon or a hexagon. It is infinite. We still have another friend of ours called the square. The square, sorry. We have a square. That's our friend, the square. So I have one. I'll try to rotate. try to rotate a square. That is a square. We just want to know it has how many order of rotational symmetry. So we shall go to a rotation learner. So I use this one so that you'll be counting until that one comes there. We shall note it is how many rotations. So I begin. So you move 1, it has fitted. 2, it has fitted. And 3, it will fit. It is, we count 1, 2, 3, and 4. You see, it can fit onto itself 4 times. So we say a square has order of rotational symmetry, order of some rotational symmetry A equal to 4. Center is intersection of diagonals. Intersection of diagonals. So learner, at this stage, you know what rotational symmetry is. The number of times the plane figure, symmetrical figure, can fit onto itself after a complete turn, complete rotation of 360 degrees. So hope that will stick onto your head for the pentagon and any polygon. A 6-sided polygon, the order is 6. A pentagon, it's 5. Isn't it? Whether it has 20 sides, the order will be 20. So for the assignment, so you write down for those the order of rotational symmetry. So at that end, as we end the topic, I hope you've gone through what we demonstrated and it will be easy for you to deduce that. So thank you for your audience in this lesson, and let's meet in the next lesson. Bye.